Record to cloud. Good. Yes. Yeah, so looks like I'm recording the session, so that's a good start. Today is actually really fun because we are going to talk about exceptions and reading and writing files. So these are some whole new tools for in our Java toolbox. But first, we'll discuss the homework. Did you guys manage to do the homework?
I did not, sorry. No.
You did not? No,
I
no,
mean,
I
I
did.
didn't get the time actually to catch up.
Yeah, I had a really tight week time-wise as well, so
Yeah.
I
Yeah.
understand it. Um, yes, then let me just see what the homework was, and I'll just gently show something of it. Yeah, so it started with continue working from last week's project. Check, first step, we're here, last week's project. And then it said, add the items to your collections, preferably in a loop. Check the size of your collections and print these to the console. And also use your collection inner for each loop to print information about all the elements in the collection. And then also create a map in a tournament that stores the winners and losers in 2 keys with type list team. Yeah, I'll have to see about that. Let's just start with the first step. Add the items to your collection. So I think we made some collections last week. For example, for rounds and maybe also for tournaments. Yes. I actually think so. Here I'm playing the tournament, so I suppose that my round should be coming from somewhere, right? So let's just make a main method here in which I'm going to add some rounds to our rounds in our tournament. So let's first start with creating a tournament. There we go. Do I have a default constructor? Luckily I do. And then if I look at, for example, the rounds, it's of type list round. So I'm going to say tournament.sets rounds. And in there, I'm just going to say new array list of type round like this. Yeah, and it says I don't need to specify that, sure. Then what I want to do, I want to add some rounds to our tournament. And actually, I want to add 3 rounds. So I'm going to say for int I 0, I smaller than 3, I plus plus. I'm going to say tournament dot gets rounds dot add a new round. There we go. Just like that. Oh no, I don't have a default constructor in round any longer. So let's check out round and maybe actually improve my life quality and just give it quickly a default constructor. There we go. So I can do that now. So I added items to my collection of rounds in a loop. So that's a great start. But actually what I also want to do, I want to add something to my round maybe. So let's see what our round object looks like. It has teams, it has games, winners, and a round name. I actually don't want to set the teams, I think, because I'm setting the teams probably based on who's still playing. Yeah, so I'm adding them here. So I don't need to do that. But I can make some teams in here. And these teams, they can be added to my tournament. Like here, the participating teams. So how many teams do I want? Well, I have 3 rounds. So in the last round, there will be 2 teams. The second round has 4 and the first one has 8. So I want to have 8 teams for my tournament. Well, if you're going to look at a team, we have amateur teams and professional teams. And team, it doesn't have a list of players yet. So let me change this. There we go. Let's see how I can do this. No, okay, let's just say it's a list of players and then just change it everywhere. That's fine, I guess. There we go. Change it here. Change it. Oh, here and there as well. So in here, I want to add teams, and also to each team, I want to add at least 11 players. So I wanted to add 8 teams. So let's go again. I smaller than 8. And I plus plus. There we go. So I want to add 8 teams. So I can just say, just like what I did on top here, I can say tournament.sets teams, new array list. There we go. But this is slightly more complicated because I want amateur teams and professional teams. And actually, I'm going to add this still in one loop. So I'm just going to say if I is an even number, then I'm going to add an amateur team, and else I'm going to add a professional team. Tournament.getRounds.add. I'm not sure what I promised, but let's just go for one of these. And also one here. Oh, there's something else going wrong as well. Public. So here it still has the array of players, which by now should be a list of players. No. Same thing here. Hold on. What's the problem? Oh, I'm kidding. This should be get teams clearly, because now I was trying to add a professional team to a round, so that's not going to work. All right, so there was a little detour to get this working, but let's now say get teams dot add new amateur team. So now in this loop, I'm adding teams to my contest. But what I would also want to do is actually set players to each of my teams. Do I want to do that time-wise? Let's see. No, I don't. I think it's clear, right? You can just add stuff to your instance in a loop. Is that all right for you guys? You understand that? Yes. Look in the chats. Good. Yes. What do you mean, Daniela? Explain with instance. So this is an instance of the tournament, because I'm saying new instance of type tournament here. Yeah. I'm really looking at this last point. Luckily, no one did the homework because I actually don't understand the last point. I think I'm going to remove it from the assignments. Well, we can check the size of our team, clearly, of our teams. We could say something like, this is not Python, like, say something like tournaments dot get rounds dot size, and then we'll be printing the size of our rounds. And these teams here, I didn't give them any names, but if I would have, I could have just said for every team in tournament dot get teams, and then say something like print t dot gets name. But I didn't give them a name, so this will just print null. That's not very interesting. But this is the way you can do it for each, and this is the way we can get the size of the round. And this is how we can add items to our lists. Any questions? No? All right. Good. Let's move on then, because I already said that this week is going to be fun. Well, it depends on what you think is fun, but I think exceptions can be quite fun. What are exceptions? Exceptions to actually occur when something is going the unhappy path. So for an example, I had an exception this day because I was going to the forest with my kids, and my daughter, she had like major tantrum. And it's something I would consider an exception because it's the unhappy path, but it's not so bad that everything completely crashes and stops. There are protocols in place to kind of deal with this tantrum and then still continue what you want to be doing in the first place. And that's the same for exceptions. So exceptions means something went wrong, but in very many cases, you can recover from it. So you can make some sort of protocol, and a protocol that will be done to deal with the exception. So we can handle these exceptions with protocols. So there are some sort of error, but in Java, there's a really big difference between an error and an exception, because an error you cannot recover from. It's like an out-of-memory error or a Stack Overflow error, just really big problem. That's an error. An exception means that, okay, well, maybe we can still fix this. That's kind of, yeah, the way that's spread. So let's have a look at a few exceptions. You have probably seen some of these already. And for example, here we have an array, and this array has an index 0 and an index 1. So if we try to grab index 2, we get an array index out of bounds exception. And a clear message. It says index 2 out of bounds for length 2. And also it says where exactly that is happening. So you get quite some clues from Java as to what's going wrong. And then this one, this is usually harder for beginners to get, the null pointer exception. What's happening there is that you try to do something on an object that is null. So for example, just to give you an example of a null pointer exception in real life, if I would ask Leon, hey Leon, do you have a dog? And he says no. And then my next question is, so what's the name of your dog? He'll probably be like, what? Null pointer exception. Because he doesn't have a dog, so the dog cannot have a name. And this is kind of what is happening in Java as well. So when you try to access something on an element that there is no instance from yet, so in this case, there isn't a dog, then you cannot actually get anything on it because the object is null. There is no instance to be working with. So that's the null pointer exception. And we have another exception on our slides over here, and that's the class cast exception. And that one's actually a bit more interesting, I think, because this is happening when Java tries to do a cast, but it cannot actually cast that object to that type. So during compile time, it doesn't know. It will just try to do the cast because it's possible that it might succeed. But then during runtime, it discovers, oh no, I cannot do this, and it will throw a class cast exception. And in this case, it's happening because we try to, we have a dog over here named Java, and we have a Chihuahua, and Chihuahua is a child class of dog, but it's more specific. So you cannot just cast any dog to a Chihuahua because this isn't a Chihuahua, it's a dog. So you get a class cast exception. Does that make sense? Yeah?
Yes, Mike, I have a question about the null pointer, specifically related to the example. So why does it have a null pointer exception here? Because it's setting on the first element, I believe, of the dog.
Yes, This is misleading. So I'm not setting the dog over here, but I'm setting the dog array. So I'm actually making an array for dogs with size 2, but there's 2 nulls in there now. So index 0. Yeah. Do you see?
Yes, I understand what you mean. I mean, I will type it and then I'll understand more, I think. Yeah.
Yeah, maybe try it.
Yeah, yeah, yeah.
That will help.
Yes. Yeah.
So these are all exceptions that are actually my fault, right? This is just bad coding practices. And there is a difference in Java between 2 sorts of exceptions. We have the checked exceptions and we have the unchecked exceptions. Unchecked exceptions, they're usually it's the programmer's fault kind of thing. So the ones on the previous slide, they were all unchecked. We could have avoided this from happening with checks before actually doing something. We should have done that. But actually we shouldn't, because I wanted to demonstrate exceptions. But anyways, we also have checked exceptions. And checked exceptions are different, because checked exceptions, they are actually expected to be happening. So therefore they need to be handled. And with that, I mean that sometimes there is a situation where something is happening that's not per se something that the programmer can do anything about. And what that means is that then actually the exceptions, they are expected to be thrown because it's not in your control. So something that's not in your control, that just means it can happen because you don't have control over it. And this is when you'll have to deal with the exception. And if you don't, you'll get the compiler in IntelliJ giving these red thingies underneath your code, and it says unhandled exception. How do you want to proceed? And then you pretty much have 2 options, well, maybe 3, depends on how you look at it. You can do it with a try catch block. I'll show you that on the next slide. And you can also do that with a try with resource block in some cases, which I will also show you on the next slide. And you can do this with adding it to the method signature, which I'll also show on the next slide. So if there's no questions about this, I think I'll move on to the next slide. That must sound very promising by now. Any questions regarding exceptions? One thing I want to add myself, though. These checked exceptions, they all extend exception. And these unchecked exceptions, actually, that's more the case because they all extend exception as well, indirectly. But these all extend runtime exception. And if something extends runtime exception, then it's not a checked exception. If something doesn't extend runtime exception, it is a checked exception. So that's important to know. I'm showing it in the video of this week as well. So it's actually very common for Java instructors to combine exceptions and writing and reading to files, because this actually involves exceptions and dealing with exceptions. So there's a lot happening here because I'm going to explain 2 things at the same time, sort of. Well, I'm going to try not to do that. So please ignore all the file writing stuff and first look at the exception handling. So this file writer, this is a Java class. And this Java class, this might actually throw some sort of exception. And this exception, you can see it here. If I just type new file writer, it says unhandled exception. So as soon as I'm starting to use a file writer, I will have to put some protocol in place. And this is a way to do that. I can say, try to work with this file writer, but catch this IO exception. And if it occurs, then do this. And then you can have a finally block that's optional. And whatever you put in a finally block will always be executed. So here we have the code that might throw an exception. And here's the code to deal with that exception. So that's way 1, I would say. Try, catch, finally. We also have auto close, and this is only for some classes. So for example, file writer, it is an auto closable class, meaning that if we do the try catch slightly different, we don't need to close our file writer. So here we need to have a close statement. And this is a special try catch in which we don't need the close statement anymore. And that's very beneficial because if we get an exception here and then we go there, our file writer will remain open, and that's a problem. Whereas right now, if we have an exception here, this block will still make sure that the file writer, which has been opened between these parentheses, will still get closed. So this is actually slightly better in this case. And then there's one last way, and that is just to, I always call this throwing the exception up to some extent, because you're saying, I'm not dealing with this. Whoever is calling this method should be dealing with this. And in this case, it's the main method. This is terrible practice to make the main method throw exceptions, but yeah, it's just an example here. I see Leon laughing. Yeah, it's really bad, I know. So whenever I would be calling this main method right now, I would have to deal with this exception, this IO exception. And then again, I can still say that added to the method signature or whatever I am, but this is a bad practice to some extent. There are actually patterns for this, but it's too much for now. So that's about exception handling. Let me now dive into the other stuff that's actually happening here, which is writing to a file. So this file writer, this is a very special Java class that we can use to write to a file. And we can do that with the method write. So we have a file writer, and we just say .write, we insert some text, we close our file writer, and then it's actually going to generate a first file with this very inspiring la 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 in it. It's that easy. So you just have a file writer, you do write, you do close, you're done. But you'll have to surround it with a try catch and stuff. Does that make sense? Good. Yeah, all right. Let's now move on to reading to a file then, which is slightly more complicated, but also not that much more complicated. So as you might have guessed, there is a special class in Java, and it's called file reader, which we can use to read from files. And again, it might throw exceptions, so we need to surround it with try catch, and we have to catch the IO exception it might throw. So what I'm doing here, I am saying create a new file reader, and I want you to read this file, first file.txt. Then in here, I'm going to do something that might look a bit weird, so this will need some explanation. I'm going to say I want an integer I, because this read method, it's actually giving back an int. And when it reaches the end of file, it is returning -1. So as long, I'm saying, while the int doesn't equal -1, so as long as the end of my file has not been reached yet, and in this case, I'm just going to print it to the console. If I would just say I without the char in front of it, it would print only numbers, and I actually wanted to print the characters. So I'm saying I want to cast it to a char, because then it will simply print la 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 to the console, because that's what's in the file. If you don't add the cast to a char, it will print the numeric value for it. So it won't be very readable. And then I close the file reader, or you can do the try with resources again. And I'm catching the IO exception. And that's it. This is how to read from a file. Is that clear? Because I can imagine at this part, it might be a bit, I don't know, a lot to look at if it's your first time looking at this. So yes, it's clear. Why I'm defining I? Because I want to store whatever I'm reading. And if I am putting it in here, I'm not sure. I don't think it wants to do that, having to redefine it every time I'm looping through it. So I'm first defining I, And then whatever I'm reading, I'm storing in I, and whatever I read, I'm printing to the console, but then casted to a char. What means E? Ah, yes, good point. So here I'm having the catch IO exception E. And this is just like saying dog D. So IO exception is just a Java object, meaning I have to give it a name when I want to refer to it here. So I'm catching whatever IO exception that might be thrown, and I'm calling it E. So then in here, I can call e.print stack trace to get the stack trace of my exception. Can we do without I? Well, you could call it different, but you'll need it, I think. Because if you would be writing it directly, how would you check for -1? Yeah, so in order to be able to check for -1, we have to store it into something temporarily, I think. Any other questions? That's yes. So Shalika, if I wouldn't store it, it would read the character and then just read the next and read the next and read the next, but I couldn't print it here.
Mm-hmm. Okay.
So that's a problem.
Gotcha.
Good. No other questions? No? All right.
I have a question.
Yes.
It can be every letter from the alphabet?
Yes.
A, B, C, it doesn't matter?
Yeah, and also special characters. Because if you remember, char goes from 0 to, I think, 65 something thousand. So really a lot. Yes.
So can it not read like a file word-wise or string-wise? It has to read letter by letter?
The file reader has to read letter by letter. But there are many other actually ways to read a file in which you can read strings or read the whole file at once, which can be tricky though, because if you read the whole file at once, you might actually run out of memory if it's too big.
Oh, okay.
Yes, but there are many other ways to read and write files actually.
Oh, okay. Okay.
Any other questions? You may hear some fireworks, I think, in my background. All right, if you guys don't have any questions left, I'd say you're up again. I am going to put this session on YouTube, and I'm also going to watch. Actually, I have to watch them still because I need to edit them quickly right now. But I'm going to put 2 videos online, one on exception and one on reading and writing files. And I'll explain it in a bit more detail there, I think, so you can have a look. And if you have any questions, post them under the video. And I'll add the homework to the comment section again, and some extra articles for you to read. Yes? All right, that's cool. Thank you so much for joining again. And I hope to see you all next week. Bye-bye.